Before we go any further in our journey through our assembly language, I thought I would show you a quick cameo of the entire instruction set. So what we have here on the left are examples of the instructions. So these are actual instructions that the assembler will actually assemble and generate the machine code for, and we could actually run them. Now we have a description of each of them, and I've tried to make it as simple and descriptive as possible. And we also have the hex value for the instruction. Now I'm not going to talk through every single one of them because it would just be a little bit dull and boring, and you can always slow this down and have a look and read the instructions for yourself. Now there's some of them that we have already encountered. So for example, the very first two here, the data hash 5R0 puts 5 into register R0. Nice and simple. Data hash 500 puts the number 5 in memory location 500. We've seen the compare. So we compare in this instance the value of 5 with the contents of the memory location 500. And we've seen the load command. But now you can see here that we actually have 1, 2, 3, 4 load commands, and we have 1, 2, 3, 4 store commands. So this gives us examples of different addressing modes. And I'll talk a little bit about addressing modes in a different video. But in effect, it's the same command, the load and the store, but we just change the manner in which we go and retrieve the information, or we change the manner in which we go and place the information into memory. And that will become apparent whenever we have a look at the addressing modes. Now, we mentioned as well, we've seen the jump command, and with each of these you'll see there's always maybe 2, 3 or 4 different values or examples of them, and these are all examples of the different addressing modes. So we have our jump here, and we have another one down here which is our jump to subroutine. So the jump one will just take us to whatever line we ask it to go to, but the jump to subroutine is more interesting because the jump to subroutine involves something to do with the stack. So let's say for example you have a subroutine which calls a subroutine which calls a subroutine, so you're nesting all of these subroutines. Then in order to get back up to the top again, we have to, if you like, have a little path that we can take down in and a path we can take back out. Now in order to generate that path, the jump to subroutine uses the stack, but we'll see that in a different video. But just a little aside here. Now we've seen the push and we've seen the pop. There's another one here we haven't come across, and that's the move command. So in this instance what we're going to do is we're going to use the move command in order to move contents of memory locations. So for example, this move 10, 20, it'll take the contents of memory location 10 and I'll stick it in memory location 20. And the move R0, R1 will move the contents of register R0 into register R1. And we've got an exchange register, EXGR, and it will swap the two values of the registers around. We've seen the subtract command, we've seen the add command. We've also now got our Boolean commands, and we will cover that in another video. And you can see each of them again has addressing modes. So the Boolean commands are shift left, so we can shift the value left, or we can shift the value right. We can not them, that is, we can invert the values. We can perform the logical AND, the logical OR, the logical exclusive OR. And whenever we go through these, I'll show you examples of where we actually use them within our programs. And we've seen already the compare command, we've seen the increment. There's also a decrement command, so rather than adding one on, we subtract one off. We have seen before the jump if equals. But I'll go and I'll create another video, full video on the conditional jumps, because it doesn't just jump if it's equal, it'll jump if it's carry, it'll jump if A is less than, A is greater than, and there's 12 different versions of this conditional jump, and we'll show you that in a different video. We can also exchange the memory locations, so we can take the contents of memory location 20 and 40 and swap them round about. We've got a clear flag, we've got the end, which we've seen our subtracts, we've seen our multiply, our division, we've got a ret, which means the return from a subroutine, so this gets used in conjunction with the jump to subroutine, and we'll see that whenever we start building up subroutines and it'll all become apparent what it's about. We can clear the values off of register, so this will just set the registers to 0. There's another nice little thing which I'll show you, and I added it in at the end as part of our graphics. And this is a splash screen. We can also place a pixel onto the screen. So this is the, if you like, the bottom level of our graphics library, which is simply to put a pixel on the screen. Now, from putting a pixel on the screen, we could extend that to putting a line, a circle, and we could do all sorts of different, a triangle, a square, and we can get all sorts of different shapes just from that initial command for pixel. Now, there's another couple at the end here, which are another extra load and store commands, which are just different addressing modes, which I found useful to add to the mix. So that's all of our examples of our instructions, and I believe there's 81 there at the moment, but this may change and some will get added in. I doubt if any will be taken away, because if we take away the commands, then it means the code we've written previously won't work. Okay, so we don't want to do that, but we can add commands in, and we will do that as we work further along in our full design cycle. So that's all for this video. Quick and easy. You can take your time and you can pause the video and you can have a look and see what the commands are, and you can have an understanding of how they work, but we will cover them all over the next few videos. So thank you for listening. I'll get you on the next video. Goodbye.